Hi, Bobcats. In this video, we're going to look at some example problems related to alkanes. These are all things that I would expect you to be able to do on homeworks, quizzes, tests, that sort of thing. Here's our first example. For an alkane that contains 5 carbons, write the name and formula, then draw the Lewis dot structure and structural formula, and the zigzag structure. Great. So 5 carbons. What do we do with 5 carbons? Well, if we're going to name it, because it's an alkane, it's going to end with ANE. And because it has 5 carbons, we're going to use a numerical prefix that means 5 carbons. This is one of the ones that sounds like a number. 5, we're going to use pent. So when we put those two things together, the prefix pent and the suffix ane, we end up with pentane for the name of the alkane with 5 carbons. If we want to write the formula for this, alkanes consist of carbons and hydrogens. Because it has 5 carbons, we put a subscript of 5 on the carbon. To get the number of hydrogens, we're going to do that number times 2 plus 2. So it's 5 times 2 plus 2, which gives us a total of 12. So pentane has 12 hydrogen atoms. To draw the Lewis dot structure, the backbone of this molecule is a chain of 5 carbon atoms. So start by drawing that chain. 1, 2, 3, 4, 5. It's understood that every carbon wants a total of 4 bonds. So we add to the structure enough hydrogens to give each carbon 4 bonds. When we draw these Lewis dot structures, we make everything very square. We go above, below, to the left, and to the right. So for this first carbon on the far left, we can draw a hydrogen above, a hydrogen to the left, and a hydrogen down below. On that second carbon, we're going to add a hydrogen above and down below. Notice that if I fill out above, below, left, and right, so that the carbon has a bond going in each of those directions, it gets 4 bonds. So as long as I've got up, down, left, and right covered, we've got the carbons taken care of. Hydrogen only wants to make 1 bond. So by the time we've bonded it to these carbons, the hydrogen's all good. All right, so that would be the Lewis structure for pentane. We were also asked to draw its structural formula. In the structural formula, we're going to list each carbon and what is attached to that carbon. There are 5 carbons, so we're going to have to write C 5 times, and then immediately after each C, say what is attached to it. So for this first carbon, this one right here, it has 3 hydrogens attached to it, so I'm going to write CH3. Then I'm going to tackle the next carbon. The next carbon has 2 hydrogens attached to it, so I'll say CH2. The next carbon also has 2 hydrogens, so it's CH2. Same for the next one, CH2. And then finally that last one is CH3 again. The alkanes tend to have a whole bunch of CH2s in the middle. When you start drawing larger alkanes that have a whole bunch of these, there's a shortcut we can use, which is for all of those repeating CH2s, we can condense them. So I could rewrite this formula as CH3, and then I'm going to use parentheses and write CH2. Then outside of the parentheses, as a subscript, I'm going to say how many times that CH2 repeated. It repeated 3 times. And then after that third repetition, there's another CH3 group. So I can condense the formulas down a little bit that way. And then last but not least, we're asked for the zigzag structure. When you draw a zigzag structure, the endpoint of each line segment indicates a carbon. So if I'm going to draw the zigzag structure here, I want to draw 5 carbons. So I'm going to start counting where I first touch my stylus to the tablet. That'll be carbon number 1. And then as I go through and do the zigzags, each time I turn, it's going to be another carbon. So here we go. I need 5 total. So 1 where I'm starting. Oh, this is going to do weird things for me. Sorry. Let me try again. 1, 2, 3, 4, 5. That's going to be my pentane. So we're going to do, it ends up being 4 line segments because you need 4 bonds to connect those. Wait, 1, 2, 3, 4. Yeah, that's 4 line segments because you need 4 bonds to connect the 5 hydrogens. When we draw the zigzag structures, we do not write all of the hydrogens. It's understood or implied that those hydrogens are there. All right, let's go backwards. The activity that I assigned y'all asks you to go backwards for a bunch of compounds. So we're going to start with just an alkane, and then we're going to move to some more complicated examples. Remember that the endpoint of each line segment's a carbon. So I've got 1, 2, 3, 4, 5, 6, 7. I've got 7 carbon atoms here. So if I'm going to go backwards, I want to draw the Lewis structure from this. So I'm going to draw 7 carbons in a chain. 1, 2, 3, 4, 5, 6, 7. And then I need to make sure that each carbon has 4 bonds by adding hydrogens. So 1, 2, 3, 4. Oh, whoops, sorry, that was 4 going to the carbon. Now for the second carbon, it's got 2 bonds already going to carbons. I added a 3rd bond with the hydrogen down below and a 4th with the hydrogen up above. So I'm just going to go in and fill in all of the positions, top and bottom on all of these carbons, left and right, if it's missing one to the left or to the right. And that is going to complete the Lewis dot structure because now all of the carbons that we show have 4 bonds. They're filled in with hydrogen. Now, to get the formula, we can count the carbons and we can count the hydrogens. Well, we already counted that there are 7 carbons in here. Each carbon has 2 hydrogens attached above and below, so that would make 14, and then there are 2 on the end, so that'll give us a grand total of 16. So the formula for this compound is C7H16. Now I realize that a lot of y'all arrived at that as soon as you realized there were 7 carbons in this compound, but I wanted to go through the process with something that was relatively straightforward before we jumped into more complicated molecules that are not just alkanes, because we can use this process to figure out the chemical formula of these more complicated molecules as well. So let's try this one. This one is a compound called ethylbenzene. And the end of each line segment is a carbon. And I think just like we did in the heptane example, it would be a good idea to just completely redraw this. I can make it a little bit bigger so that it's a little easier to write in the hydrogens and count all of them. And then let's see, I still have a carbon going up here and another carbon here. Now, what I want to do here is just make sure every carbon has 4 bonds. So if I start all the way at the top, I'm going to have to add 3 more hydrogens to that top one because it only had 1 bond. If I move down 1 atom, that carbon has 2 bonds, so I'm going to have to give it 2 more to get a grand total of 4. If I move down 1 more carbon, look at that, it already has 4, so I don't need to add anything. If I move from the top of that ring over to the right 1 position, to the left it has 2 bonds, going down it has 1, so that's a grand total of 3, so I just need to add 1 more. If I go to the next carbon, working my way around the ring, it already has 3, so I'll add 1 hydrogen to get 4. And ditto for the next carbon. Each one of these carbons in the ring already has 3 bonds, so I just need to add 1 more hydrogen. Great, so we now have that Lewis structure fleshed out. So to get the formula, we just need to count atoms for carbon. And honestly, sometimes when the compounds have a lot of atoms to them, it can be a little tricky to make sure you count them all accurately. So I'll sometimes do what I just did here and number the atoms. So in terms of the carbons, we've got a grand total of 8. And now for the hydrogens, well, let's see, carbon number 1 has 3. Carbon number 2 has 2, so 3 plus 2 is 5. And then the others are all singles, so 6, 7, 8, 9, 10. So C8, H10. All right, let's take a look at the next one. This last example is throwing in some elements other than carbon and hydrogen. And I want to assure you that for Chem 1320, if I'm throwing in other atoms, you do not need to worry about adding extra hydrogens anywhere. You only have to worry about the carbons for that. So for instance, here, the nitrogen atom is shown having a hydrogen attached, and the oxygen that's down at the bottom has that hydrogen already showing. You don't have to worry about adding any others. We just deal with adding hydrogens to the carbons. So if I'm going to come up with the formula for this one, I'm going to need to there we go. I'm going to need to write out what all of the atoms are. So I'm going to start with that benzene ring, that ring of 6 carbons that's the lower half of the molecule. I'm just going to go ahead and draw these 6 carbons in a hexagon. They have alternating single and double bonds. So let me go ahead and throw that in there. That bottom carbon has an OH. And then let's see, the top carbon is attached to a nitrogen. That nitrogen has a hydrogen on it, and then it's also bonded to a carbon. That carbon has 2 other bonds, or has actually 3 other bonds already showing. It has a single bond to a carbon going up top and a double bond to an oxygen to the right. Okay, so let's start filling in the hydrogens to make sure that every carbon has 4 bonds. The very top hydrogen needs 3 more. And the carbon underneath that already has 4 bonds, so we don't need to bother with it. We don't need to bother with the oxygen or the nitrogen. I'll always give you whatever's attached to heteroatoms, to things other than carbon and hydrogen. The carbon at the top of the ring attached to that nitrogen. Whoa, what did I do? Sorry, I got a little weird in how I was doing my alternating single and double bonds. That should be a double bond. There we go. That is much better. So now that carbon that's at the top of the ring is, it already has 4 bonds. The moving clockwise around the ring, that next carbon has a double bond plus a single bond, which is 3. So I need to add 1 more hydrogen in there. Continuing clockwise, that next carbon has 3 bonds, so I'll add a hydrogen to give it 4. The carbon down on the bottom of the ring already has 4 bonds. Continuing on, that carbon only has 3, so I'll give it 1 more, and ditto for the next carbon. Great, now we're ready to count our atoms. We're going to have carbons, we're going to have hydrogens, we're going to have nitrogens, and we're going to have oxygens. So for the number of carbons, there are 6 in the ring, plus up top there were 2 more. So that gives us a grand total of 8 carbons. The hydrogens up top, we've got 3. There's 1 attached to the nitrogen, that makes 4. And then moving around the ring, we have 1, 2, we already have 4. Moving around the ring, that adds 5, 6, 7, 8, and 9. So that gives us a total of 9 hydrogens. There is 1 nitrogen, and there are 2 oxygens. So there is our chemical formula. This compound is acetaminophen. It is the active ingredient in Tylenol.